Just to get going, how many people have been maybe to a cloud native either national event or maybe in another city or anything like that? A few. So this is something that Branden and I actually at the end of 2017, we went out to the cloud native event in Austin at that point in time, and started talking about getting something started in here, because this space to us is a very interesting space. A lot of benefits to companies, our own, and within the community. So this is so something that we wanted to start up and share our experiences with community. Have other community members share as well. So it's glad to see such a nice turnout here tonight. So just to get started, my pointer is not working. Hit it harder. That usually works. Did you hit that or did I hit that? Okay, so we'll see how this goes. Again, it's first time. So restrooms, if you haven't found them already, are back tucked around the side over here down the hall. There is stairs in case of any sort of emergency in a concrete building and steel, probably not so much of an emergency tonight. Down over to the side over there. You notice there's some cordoned off areas. It is a working building and whatnot. If somebody is interested to look around, you can find myself or there's several other employees of Arms Business Solutions that can give you a quick tour, maybe during the break or after Branden's speech later on. Also, as you see, the deck is out here and it is open. If you wanted to go out there, there's no water on it, so you don't have to worry about slipping coming in. That is one of the things when we get some snow and ice out there and you come back in and the nice polished floor, you could slip. But feel free to walk out there, walk around the areas that are not cordoned off. So. That doesn't seem right either. Oh, maybe I've been hitting the wrong button. Oops. Okay. There we go. I think I got it. So this is our first one. I did update the Meetup site with code of conduct. Ultimately, we do want to be listed on the Cloud Native website as a official meetup. It's going to take a few meetups to get listed out there. But one of the things is, we need to follow their code of conduct. There's links on there. There's links on the Meetup site for that. Long story short, it's treating everybody with respect, whether it's a speaker, other people in the audience, just whatever. Just treat everybody with respect. Wouldn't expect anything else. Normally, if there is any issues, you can see myself or Branden, and we'll take care of it. Hitting the wrong button again. Other business. So the next meetup, we do plan, like on the site we said, the first Thursday of every month. That's going to turn out to be April 4th. We'll do that again at this location. But we do, and maybe even somebody here tonight, we are going to be looking for other locations. Ultimately what we want to do is spread this around from the east side down to central part of the city, and all the way to the west side to get a good coverage. And we understand, it's sometimes hard to get from one side to the other, especially if you live around that area. So we do want to move this around eventually, but I expect the first 2 or 3 will probably host right here. On that note as well, we would love more speakers as well. We do plan on ultimately getting some of our vendors to help us out with some speakers as well. That just didn't line up for today, but we here at Arms Business Solutions leverage all 3 of the major cloud providers, and so we would hope that we can get some of them to come speak with us about some of their specifics, and we also have plenty of tool vendors that we're open to. But we also want to make this very much a Madison community local type thing as well. And so share our local experiences and just like tonight, I'm gonna go over our journey here as a company of how we got to where we are. And I just love those journey stories, even those I think can really help. Brandon's going to go a little more technical with his, but yeah, whatever you can do. You don't have to be a great speaker. I'll probably be the third best speaker here tonight, and there's only 2 speakers, so we can all do this sort of thing. I am not used to this. Sorry, Gina. Did I skip a slide? Oh, I did skip the slide. Sorry about that. Yeah, so tonight is sponsored by Google Cloud, and we do have Scott here from Google Cloud, so feel free to talk to him. Yeah, so they provided all the food and beverages tonight, and I have some swag, and we'll go ahead and for both presentations, I think we'll give one of the water bottles, which I had out here. Really cool water bottles. They're nice and glass. So we'll give out one of these for each one of the questions after each one of the presentations. Then we have another one, and I think we'll do a water bottle plus there's other goodies in the box, and I think we'll give out one of each for the first person that wants to sign up for like next month for a presentation. And then again, we are here located at Arms Business Solutions, and we of course thank them for giving us the generous space here as well. And there's a lot of work here that certainly came in. Yeah. This room isn't normally set up like this, so we went through a bunch to get this all set up. So we definitely thank that. So yeah, so got through all that. Oh, and yeah, a lot of us are here to connect and whatnot. And so maybe everybody else knew this, but I certainly didn't. But in the LinkedIn application, there we go. There is a Find Nearby button in your LinkedIn application. If you just turn that on, and it'll find people next to you, and you can connect if you want to. Obviously, totally optional if you want to do that and connect up. I was going to have mine set around so you could see me on there, but I didn't do that before I got up here. So with that, then, we sort of get into, oh yeah, I have my own bio there. I moved around these slides this morning. So yeah, so I am a 24-year, give or take, professional. Most of my background is in software development. Java, in fact, if I go way back all those 24 years, I was actually training COBOL, but I'll never put that on a resume again. Although there's pretty good pay for that these days, so not too bad. But I've gotten into all sorts of different technologies through my roles through the years. I technically have an architect role, but I hate the titles like that. I don't think there's any difference between an engineer and an architect, and so I try to get into everything that I can, including in the infrastructure and the operations of an application. And of course, a lot of what Cloud Native offers is just that, is the operation of the application. I do love to tinker with tech, even outside, and I've been playing a lot recently with the Arduinos. And I don't have a picture. I should have had a picture of my daughter's cage up there, but I have the Arduino controlling her snake cage. Her mother hates the snake, so it's really cool. So Cloud Native itself, the CNCF, has a good long definition for what Cloud Native is. I'm not going to read through the whole thing, but I'm assuming many of you have already seen that that definition. And well, it's a very good, clear definition of what Cloud Native is. I sort of have a little more concise definition for what I believe Cloud Native is, and that to me is diversity. And I really first saw this again when Branden and I went out to the Cloud Native in Austin, is and if you've ever been there or seen any of their stuff online, I mean, they have diversity scholarships. So at that point in time, I think it was probably 15 or 20 diversity scholarships that they gave out for people to actually to come to it. And to me, that's really cool, but it really highlights not only the people diversity, but also the companies that put effort into it. You know, I think most of us know that the Cloud Native Foundation was created when Google decided to, donate Kubernetes into it. And since that point in time, not only has Google contributed to that, but you have the likes of Microsoft, IBM, Red Hat. The list goes on and on for all the contributions. You know, there's such diversity, within who's contributing to this, and that's a really cool thing. And then obviously, if you look into the technology itself, I think I'm too far away is what it is. You know, this is their current landscape. If you go out on their site and look at that. And so obviously you have all the big ones. You have, Kubernetes, you have Istio on there somewhere, Linkerd, Envoy, but there's such a diverse technology set along with this. And again, you'll see, tons of corporations that have donated portions into there, like, Lyft donating Envoy into it. So it's that diversity that I think we want to continue here at a local level. Not only, excuse me, with speakers, but with the topics that we might want to cover going forward here as well. And so again, we want to bring that diversity, into our community, and we want to, be sure that we do that. Obviously, all are welcome. And we don't really want to be too focused on, one technology. I mean, obviously Kubernetes is the big one in the space, but again, you look at that list and there's a ton of other ones out there. And we want to continually, bring in new ones of those, and even cloud providers. I mean, that's one of the great things about this cloud native landscape, that it's not really cloud provider specific by any means. All three of the major cloud providers have a managed Kubernetes at this point. They're all part of CNCF, members of CNCF. And even with that, there's nothing that says you have to use a cloud provider at all. You can do Kubernetes on-prem. Again, it brings in the diversity of that. Although for tonight, Google Cloud's going to be our favorite since they did sponsor us. So. Oops. So early on, about a month ago, when we started setting up the Meetup site, Branden sent out a survey, and we got a bunch of responses of that back. And I'm not going to go through all the responses with this, but this one sort of caught our attention with it. That if you look at those top, let's see if I get the laser pointer right. Yeah. So if you get the top two there, that's really from the people that took that survey, is how many were actually using either Kubernetes or any other cloud native technology in production. And that really sort of surprised me, and it excited me at the same time, that within our local community here, that we are utilizing these technologies. So that's really good. The other parts of the survey were asking about very specific technologies, and I'll tell you that pretty much every technology that was listed there, everybody was either a 4 or 5 on the range, wanting to learn about and whatnot. So I think it gives us a lot of content going forward in terms of the topics that we can provide, and as a community we can share with each other. So without further ado, I'll get into it. If you looked at the Meetup site, Branden and I switched it up here at the last minute. He was supposed to present first, but we decided that I'll present first. Sort of flowed a little better that way. And so I'll be honest, I did switch up even my title of this morning. So we'll see how this all goes. I think I have it down at this point. But if you remember from the Meetup site, the original title I was going to do is something like Journey to Cloud Native or whatever. Wasn't or wherever, but But I decided, as I went through it a little more, and it's like really, cloud native then sounds like a destination. And the reality is we're not going for a destination with this. It's really the journey that we're going on to. So thinking about that, so it's our journey to infinity. And again, this is going to be somewhat of a little bit of a short history of where we were as a company and what steps that we took, to get to where we are today, the technologies that we brought into that. By no means is this prescriptive in terms of something that you might want to do right now. Again, we started this several years ago, this journey. There's probably different steps that you would take to get here today. But again, this was our journey. And again, I would be curious to hear other journeys of companies as well. I think that sharing these experiences like this help us all, even if it's not necessarily what we would do today. So as I was thinking about that, and then it came up with that title, last night I was watching one of my YouTube shows that I really like to watch. Does anybody know who? SV Delos, that's correct. And it's sort of the same thing. So the background with them was about 8 years ago or so. Brian, right there, decided he was going to sell his house, pretty much everything that he owned, buy a sailboat, and just travel the world. So he had no destination that he was going to, but he just wanted to essentially always be on a journey. And so that's what he's done for the last 8 years, and well documented right now on YouTube. And it's actually a really good series. But it's sort of the same thing with what we're doing here. Is we jumped on this and we're going with it, but really there's no destination that we're going to at this point in time. We're always just taking the next step. So they go from one island to the next. They get to a location. They don't know where they're going to the step after that. And really, the journey, and a lot of times the journey in software development is just that. Is you take that next step and then something else is there. And so our story then begins back in the early 2000s, this before my time at this company, maybe back even in 2001. I know I'm hitting the right button. There we go. So the monolith was born. So it was a small team, small code base. Everything was good, and there's really nothing wrong with a monolithic application. You have a small team, small application, you can live with that forever. There's no real reason to go beyond that. But we grew, and we grew the number of developers, we grew our code base. I think at this point in 2015, we had 1,300 tables or so in our database schema. Maybe 2-3 million lines of code around it. So it got a little too hard to handle. And I think we probably had about 40, or probably not at that point in time, probably at that point in time, maybe about 25, 30 engineers, trying to code onto that. So we had all the problems of a monolith at that point in time. Hard to test. Only a few years before that did we really get into the automated UAT testing. I mean, we always had the unit testing around it, but from the outside, automating those tests. And even when we automated those tests, they broke, maybe 30% of the time just because of the changing data in those data sets. We had very long development cycles, 6 weeks to go through and get code through our cycle. And even with that, I changed around my bullet points. Okay, so we also had very large efforts to upgrade any of the core libraries. At that point in time, and our monolith was using Hibernate, for a data storage, and to update that was literally, probably a full 6 week cycle to do something like that. And there's a couple of times where we had to back it off just because we missed something with that. So all these problems that we had, obviously to get around the 6 weeks, we were developing in branches, different branching strategies we had. So we started splitting up teams and doing, running 2 teams at once and, sort of, maybe trying to release every 3 weeks, but each team's still doing that. And we had had to merge at that point in time, any sort of bug fix coming through there. It was quite the hassle. Deployments took many hours, and sometimes hours doesn't describe enough, because there are sometimes we were here till 5 in the morning or so to try to get a deployment out, and we're talking pretty much a full team. We had testers, infrastructure, QA, product owners. We had everybody on there for that, so it was a large effort. And of course, we had to do this off hours because it was all downtime at that point in time. Almost always, we had to follow up with a point release or two with that to get by some of that. Again, with these long cycles like this, it's really hard to get away from getting everything correct in all of those. And so what does that sound like? Well, yes, the whole giant ball of mud at that point in time. Everybody tugging a different direction to try to get somewhere, and we knew we had to do something different. And so that was really the start of our journey. With that, we didn't necessarily officially put these principles up, but it's really sort of what we went off of. Now it's going without me even touching it. That's cool. So we wanted to be, much more automated than we ever were. We still had decent automation in terms of how we did our deployments out there, but we needed more automation, especially around the testing arena. Another one of our principles is to avoid vendor lock-in, and that is one of the things that really attracts me to cloud native, is just that, right? I can take the same type of setup and run it on Google Cloud, which of course we'll always do. Or we can, run it on AWS or Azure. We're, even could do it on-prem. So, I mean, that's something I love about that. Another big thing is to give more options. Like we said, we had Hibernate in the, as part of our monolith. And if you know much about Hibernate, once you bring Hibernate in there, it's really hard to work outside of Hibernate, because Hibernate does a lot of caching on its own. If you try to do stuff outside of that, it's not going to work so good. So bringing in new technologies, giving developers more options is also another principle that we were really strong in. And these last couple are the real big ones, right? We want to evolve, not change the world. Evolution to me is more of a ongoing type thing. You're always going to do it. There's no finish to it. When you get into these cycles of revolution, where you get everybody together and you try to get to that end game right away, again, you can think of it as somewhat of a waterfall type thing at that point in time, where you're just going for that one revolution. So we wanted to evolve and continue to evolve. The other thing is, don't look too far ahead, and I think that those last two go hand in hand. Again, you start planning out for 2 or 3 years out. How much has that changed? If you look back 3 years from now, how much of the things that you're doing today would you have thought about back then? So we don't try to look too far out. Obviously, you have to have a plan, but maybe look at that next step, maybe the next 2 steps out, and beyond that, not too much. So I think with those last 2 bullet points is where we get to that infinity, right? So we're always going to evolve, not going to look too far ahead. We can continue that for as long as we do business. Our first step in that, and this was back in, I thought I had a date up there. I think it was 2015, if I remember correctly, give or take. 2015, 2016, somewhere in there. We took one small application and we installed the Docker runtime on a couple of our servers, and it was a separate batch. We used Quartz at that point in time, so we needed one small database, called the web service, put something out on an FTP server. That's all it did, but we did that. Matt's laughing, he installed it. Very simple, but it started to prove out that isolation and that change into the technology. This is the first time really we were able to bring in a different technology. So that was our install script. Of course, I did mention that we wanted automation with all of this stuff. So instead, we used Terminator, so you can do it on both servers at once. So that was most dangerous tool that there's out there. Nobody with my sort of rights should have access to that. So what did we learn with that? So even with that small step, we knew the power of at that point it was containerization. We don't really want to go back to the old way at that point in time. The traditional install the application server and the application into it. We got great isolation with that. Like I said, we were able to, at that point in time, we even used a different version of Java that we were using. So that it was hard to do that in a monolithic application. The deploys were good. We did obviously automate it more so than just Terminator. And again, because you're installing one thing and it's all bundled together, those were pretty easy deploys at that point in time. And as I already mentioned, updated the tech, different Java stack, different libraries. We could do all that in isolation of one another. But the downfall, we did need the ability to run multiple containers, right? This was a pretty simple batch process. They didn't really know about one another. If you know anything about Quartz, the database tables will manage, which one runs on which server. But we needed a little more interaction with that. And even at that point in time, I think we knew we needed a little more better tools to actually look into those run times that we're running. But even so, Fippy was happy. Now, I don't know if anybody's, Brandon's got the toys out there, but if anybody's hasn't seen, I should have put a link to it in here, but the children's illustrated guide to Kubernetes. It's a nice slideshow, and there's a couple of YouTube videos of the author actually going out there, but this is Fippy. And they actually donated all of these into Cloud Native. Again, the great community that Cloud Native is. After that step, again, to try to get rid of a couple of problems that we had with that, we started using Docker Swarm. And if you know anything about Swarm, it is an orchestration layer. Again, at this point in time, back in 2016, maybe Kubernetes was going to be the big thing, maybe it wasn't. The one thing though, even though it wasn't a de facto standard, Kubernetes was and still is, more complicated than Swarm. So again, with our small steps, our evolution, we decided to use Swarm. With that also, we used a product called Rancher, if anybody's familiar with that. But that helps manage the run times on the servers, and then actually, sets up the networking between the servers, so all of our containers can talk to one another. It also brought in the concept of soft load balancers, and this is one of those sticking points that we always had. At this time, we were using managed servers. We weren't in a cloud provider at this point in time, so our load balancers were physical load balancers. And whenever we added an application, needed a context change or anything like that, again, we had to bring in infrastructure to do that sort of thing. So even this concept here brought in that concept of a soft load balancer, brought it into the stack. So that was one of those things that we could push to the development team to be able to make those updates. Again, giving that team a little more options with how to do things and less dependencies from outside teams. We did bring in a new pipeline about the same time that we did this. I explained that a little on the next slide, but we could probably do an entire talk on that pipeline to what we do, but I'll go over the highlights next. Now, the only time that we had to involve infrastructure at this point in time was actually for new services, new host names or whatever out there to point at that soft load balancer, and that's something they could do during the day at that point in time. Also, infrastructure was actually, still maintaining the servers at that point in time. But we could, at that with that now, we could do a no downtime deploy in most cases. There's a couple other aspects that go into that in terms of, separating our database changes from our actual application changes that went into that. But that one case that that wasn't covered under our no downtime is if we messed up a configuration in a specific environment. So if we messed up like a password to a database for a production server, we would get downtime because our health checks were calling from the outside. So everything had to be installed. Then we called our health checks, and if that configuration was bad, then the health check would fail. Then we'd have to roll it back. So we could experience, maybe a 20-second, 30-second downtime as that was all going on. So that pushed us with our requirements. That still pushed us into doing things in the maintenance window. But even with doing that, getting to that, we've put in a lot of metrics around in our pipeline at one point, about a year and a half ago or so, or a year ago. And with one of the teams right now, we saw that they were doing about 17 deployments a week, which obviously, like I said, in our old environment that we were doing basically once every 6 weeks, and with the branching strategy, we were doing every 3 weeks or whatever. So a huge improvement with the throughput for that team. And their cycle time, which we measure from the time that they commit the code to the time that it hits production, get down to 12 days. We didn't have good stats back on our monolith, but I can suspect that it was probably closer to 4 weeks or so between when that code was committed to getting it out in production. Sometimes longer for a bug fix, maybe later, but pretty impressive nonetheless that the team is able to push that out that fast. So again, I'm just going to go over the highlights of what we do with the pipeline, because I think it's important to how we get to our good testing and no downtime deploys. A fairly normal, CI build to begin with. You do your compile, unit test, build it, containerize it. Now, if you're not doing containers yet, that step's a little new, but everything else is pretty standard at that point in time. There's other things in there. We use SonarQube for tests and whatnot. So the first thing we do after it gets all through that is then we stand up an empty database, brand new empty database. And what we do is basically one database per microservice. We run the migrates from the beginning of time, to that point. We load that with seed data, and that seed data is developed along with the code in the tests, the automated tests that are going to be run. So we can make that seed data pretty much anything that we want. So we can cover all those cases. We can even cover edge cases, things that we wouldn't normally allow to put in through an API. So if we really want to start testing some edge cases, we run our automated UAT tests. And again, like I mentioned before, with our monolith, when we did our tests, we might fail 30% of those tests. Using this with that static data set, when the test breaks, there's typically a code problem at that point in time. We'll automatically, run a deployment out to our int environment. QA and prod, there are button presses for somebody to approve to go out to those. And then the only thing we do out in those environments is run a smoke test, and basically that smoke test, all it does is check those things that are unique for that environment, which are usually whether they're URLs to somewhere else or the username and password for databases and whatnot. And so those smoke tests run very quick, and we've had pretty good success with that. So what did we learn there? Again, we never want to go back to the old way, and the old way this time just being that standalone Docker. Again, the visibility is not the best between all the parts. We started to experience a little of that where, the networking is obviously a little more complicated. We're bringing that out into, we're bringing logic out into that network stack where normally in the monolith that was in the monolith. We needed central login at that point in time. I think a lot of companies probably had that before we did, but we were mostly, just going out to servers. Again, monolith, a couple servers, no big deal. We can find the logs. As we start not knowing, where those are, those logs have to come back to a central spot. Service versioning and, like I mentioned before, separating your database migrations from your code deploy are no longer an option at this point. And again, that's in order to roll forward, roll back, you have to have these things separated from when you go forward. The other thing, downfall of this is licensing can get out of the control fast. So we have APM, when we're running a couple of servers, not too much, right? It's not a problem. I think right now we probably run 100, 200 VMs or so. So you start multiplying those numbers out and it grows a lot. Now, I very much encourage everybody having an APM because they are very beneficial. Also, logging, monitoring, anything else that might be host-based or VM-based or whatever, you're going to get caught in licensing. Now, there are newer tools that will go more based off of data usage than hosts, and we're still exploring some of those options as well. And the other thing which, comes out, we always know, but a join between two services is not like a join in a database table. Obviously, it's pretty obvious, but as you start exploring out, with these services or whatnot, you have the code for that. And we try not to do caching as much as we can because we don't want to get into cache sync. So we have to do a little more bulk operations with some services or whatnot to accommodate for that. So now 50 is happy and he's got some friends along with him. So everything's good at this point in time. Then last year, we took that next step then. So, obviously there was a couple of downfalls, with Swarm. Maybe one of the biggest I don't even mention there is, I don't even think the company Docker, which puts out Swarm, is really, I think they're more in support of Kubernetes at this point in time than they are of Swarm itself. And it really is, Kubernetes is the de facto standard. So we decided we want to go with it, but we, little testing, it's pretty complicated to run. And at this point, there's really no need for us to learn all of that and put all that effort into it. When, like we said, there are all of the, at this point in time, Google was the only one that was in GA with their Kubernetes managed service. But now, even since then, the other Amazon and Azure both have managed services as well. Even with that, even right now, we do feel that Google's, is the best service. Obviously, if you look just off the basis of contributions still in the Kubernetes right now, they're just contributing most of the code into that at this point in time. Actually, it's a little less than 50% at this point, but they're still making more contributions. They seem to be a version, or at least a point version or two ahead of all the other providers, really working on that, and they do now have a managed Istio service as well. So I think it's pretty clear, at least for the near future, is Google will probably be ahead of that. Not to say that you shouldn't use any of the other managed services. I mean, they're all more appealing than trying to run your own Kubernetes cluster on your own at this point in time. So with that, we also decided to use Helm to actually do our deployments. A little simpler. I think we could template a little more out at that point in time. And I think Brandon's going to get into some of that in his presentation a little later on. But it just makes it a little more smoother getting those services out. And surprisingly, and especially surprising to a lot of people around, I mean, this is not a big step for us. We've already put in a lot of effort, like we mentioned with the containerizing and the pipeline. Those are the two big things. Going over to Kubernetes was actually fairly natural. Obviously, we had to change the some configurations around. A little different setup out to Google Cloud, but in reality, it wasn't a terrible conversion for us. And what that got us right there, along with many other things, but it got us to those no downtime deployments in all of our cases at this point in time. Am I not moving enough? Somebody move more. Apparently our lights are on a timer. Yeah, well, it might be. So we'll come back up. Oh, there we go. So what did we learn? Now we went too far. You saw Captain Cube now. Oops. Now I'm going to the end. Okay, here we go. No, one more. That's where I am. So now again, we never want to go back to the old way. That Swarm, not as good as Kubernetes. The other things we learned that it's very important to have your resource requests and limits right on your deployments. Else Kubernetes might start shutting those things down on you. The other cool thing about it is, the recoverability that we get with Kubernetes now. Now I really don't care if a container goes down. Container goes down, and if it goes down, once a month, I'm not even going to look into it. There's no point. It's just noise at that point in time, which goes to the next point is, our traditional monitoring, has to change now, and we still haven't figured out, what to do here, because it's really turning into more of an analytics exercise. I don't care if that one container goes down, but I do care if that container goes down, every 10 minutes, or if I have more, different patterns to that. And again, when we're trying to manage now, a couple hundred services, trying to get into all of that. So I think there's other levels of things that we need to go to as far as analytics go to figure that stuff out. We don't really even have to think about scaling at this point anymore. You have a min and max, and Kubernetes natively is gonna scale up containers, going to scale up nodes behind that. Really good for us. And that same team that we talked about before now went up to deploying about 20 deployments a week, and their cycle time is now down to 2 days. And now they are truly deploying during the day. So 2 days is pretty impressive for that. I'm going to throw them a party when they get down to 2 hours, because I think we can get down to that point as well. It's going to take some little more organizational changes around checking things or whatnot, but we have all the tools now to be able to do that sort of thing, which, again, ultimately everything that we're trying to do as a development team is try to give value to the business. And this is one of those big things that we can deliver value to the business extremely quick. We can recover from issues extremely quick in scenarios like this. So this is our current landscape now, where before we started with the monolith, now we have, I think Stonehenge is a great visualization of microservices. You have some bigger microservices, little microservices, some talking to one another. Not necessarily the same, all a little different, but I think that's sort of where we are today. Are you hitting? Okay, so as we said, we're at the start of our journey, right? The title here was Journey to Infinity, and since we've gone this far, we still have infinity to go. And so we're still at the start. We're always going to evolve. But we are currently implementing Istio. Love to talk to other people that have done that. Right now, we're going to start with just getting telemetry off of that. In the future, after we do that, we have a list, a couple of things, maybe some auto retries, mutual TLS, other deployment strategies, end user authentication. I mean, there's so many things in there. Operator framework. We're going to take another step at that point in time. But so I think the point of what I tried to present here is, even like I said, it's not really prescriptive of how you probably should go about a Kubernetes deployment today. But if any point that you want to take from it, it is really taking that one step at a time. Don't try to do everything all at once. Take that journey to infinity. Keep it going. Keep going through it. So, with that, as I was coming up with this, it seemed appropriate that road to nowhere is pretty much the same. So that's all I have for you today, and we'll take about a 10-minute break, and then Branden will start his presentation a little bit. Oh, sorry, any questions? Yeah, we're going to hand out some stuff. No questions? Yeah.
Can I ask what centralized metrics solutions you're looking at?
Centralized metrics. Yeah, right now, again, we haven't really dug too far into it. I did. There's a cool little tool called Harness that I have sort of looked at on the side a little. They try to use a little AI into figuring out those metrics. I'm not sure if that's what we'll go with, but right now we are still trying to do it with more of the traditional monitoring. We're just putting a little more limits at it at this point in time, saying if we're down a couple of containers in one place, then we alert on that.
Can I ask, is this strictly just monitoring the production outside, or is this monitoring the process inside?
No, we're monitoring the from the outside. The readiness and the liveness probe within that will monitor the process within the pod, and Kubernetes will kill it if the liveness dies. So, other questions? I think you got the bottle then. Okay.
All right. This is I deploy during the day and you can too, a cloud native story. This is my service owl, Captain Kubi. Don't worry, he's legit. I got papers on him. A little bit about me. So I'm an architect at ARMS as well here. Been here since about 2015. Kurt mentioned before that in 2015 we had about 1,300 tables. I was the first DBA who came in at that time. So not a super fun time. I came up through desktop support sysadmin infra engineering, so a little bit different path. I like to say that I'm not a developer, but I play one at work. So let's get started. So what are we going to be talking about? So I'm going to start by defining our context. I think that's important. Really, that's the target environment for the techniques I'm describing here. You're going to hear a lot of overlap between what Kurt and I said. I'm hoping to dive a little bit deper. It's not about how busy we are around here. We didn't have much time to coordinate our talks. But we'll be talking a little bit about kind of the case for continuous delivery. Hopefully you're doing continuous delivery, but if you're not, maybe give you some tools to help make the case to your leadership about why that's so important. And then we're going to move on and talk about software architecture concerns. And that's really going to be abstract from Kubernetes itself. I think there's some things you need to be doing, and if you're not doing them today, they'll help you move towards an environment when you really can deploy any time of day with confidence, right? Because it's important to understand that Kubernetes is sort of the kernel of cloud native, but if we're still just running Kubernetes in 5 years, I'll be shocked. We'll either be on other stuff, or Kubernetes will become so boring we don't even think about it anymore. Really, it's really the substrate for all the other interesting things we want to do. And so the software architecture concerns will apply to anything. Then we're going to get into some specifics of orchestrating deployments. Now, you're not going to see anything super groundbreaking as far as orchestrating these deployments, no downtime in Kubernetes, but you are going to see a couple of things that I kind of think about it as the missing manual for no downtime deploys. If you go and look at the Kubernetes documentation, it pretty much says define a deployment, update your image spec, everything works, yay. We found out that that's not really the case. There's a couple of things you want to take care of besides that. Finally, we'll put it all together, talk about limitations. I think it's really important to always talk about limitations and not always just paint a totally rosy picture. And we'll talk about future work and improvements. So the context, right? We're talking about SaaS transactional applications. If you're doing batch real-time analytics, it's not that these lessons won't necessarily apply to you, but just keep in mind that's what our target environment is here at ARMS. We're also talking about a microservice architecture. I totally echo what Kurt said about monoliths. If monoliths work for your organization, they're dope. Stick with it until you have to scale up. There's a lot of operational problems that come in with microservices. And really, microservice architectures are really about scaling your organization than they are scaling technology. This is an introductory level talk. I assume you know what Kubernetes is and maybe a couple of the kind of core resources that Kubernetes gives you in order to work with. So if you know what Kubernetes and Helm are, you'll probably be okay. There's some portions that might feel a little bit like Kubernetes 101, but if you're already Kubernetes fluent, just bear with me. I promise I'm going somewhere. And Kurt already said my fourth point, so I'll just skip that. So deploying anytime, how continuous is your continuous delivery? most of us are probably bought in on the idea of continuous delivery already, right? I mean, if you just think through it and you've been in the industry for a while, it kind of makes sense that if you make your deploys smaller, that they become easier to test, easier to roll back, easier to reason about, all that good stuff. And so, continuous delivery, promises these kind of things, right? Lower change fail rates, less rework plan works. You don't have these long tail development cycles, and then right in the middle, you got to go do a hot fix or change something. Therefore, you're spending more time in new development, and you can deploy those hot fixes really easily. So for a long time, we bought this, and maybe if you're doing really well, you started to measure some of this, right? Maybe you're getting stats off your pipeline that actually show these things are leading to better software delivery outcomes. But for many of us, that might have been kind of a nice to have rather than a have to have. And so applying rigor to that data in order to decide whether it was actually working may have been a little bit elusive. And so if that describes you, I highly recommend getting this book, read it, put it in the face of your leadership or whoever your technical decision makers are. These guys know what I'm talking about. So what the authors of this book did was they looked at many years of data coming back from the Puppet State of DevOps survey, and they applied rigorous statistical methods to it to say, what really are the highest correlation activities that lead to successful software delivery? And they came up with these 4 things as kind of the most important metrics that you should measure that will tell you how you're doing. And therefore, if you work on improving these metrics, you're probably going to get better at delivering high quality software. So, delivery lead time, again, how long does it take you from starting to develop a feature to it being out in production? How frequently are you deploying? Obviously, that's relevant to what we'll be talking about today. Time to restore service, obviously a big one, and then change fail rate. How many times are you deploying and that's failing, and then you have to roll it back? And so the idea here is that if we deploy more frequently, then our deploys are smaller and easier tests. That leads to lower time to restore service and change fail rate. And even if we're not on that happy path where everything's working right, we still have the ability to deliver hot fixes to our customers extremely quickly. So this really hit home for me about a year ago when I was doing a POC of Datadog. Anybody using Datadog out there or looked at it? Check it out. It's pretty awesome. One of the main things it gives you is tons of out-of-the-box integrations that basically reduce to 0 the amount of toil you have to go to start, adding your targets and monitoring them, scraping data off them. And so they happen to have this Google Cloud Platform integration, and I went there. I'm like, great. Created a service account for it, created a private key file, gave it to Datadog, hit install integration, and nothing happened. It was a UI bug, a stupid UI bug, probably a couple lines of CSS or JavaScript. But I hit the little chat button that was right there in the interface. I described to the support agent what was going on. They opened a ticket with their engineering. This is probably at about 11 in the morning. By noon, they pushed a hotfix. Like, that's amazing. I mean, especially this is not a low traffic application. There's thousands, if not tens of thousands of users banging on this all day, right? Especially in the middle of the day. And so that to me was like, that's the kind of software I want to be involved in making. That's where we have to get to. That's how you attain customers. That's how you retain customers. So that being said, how do we set ourselves up for success at a software architecture level, right? Microservices are all about decoupling yourself from basically everybody you can. And so the first thing you have to adopt if you're not already doing it as a company is a disciplined API strategy, right? And so you can read endless amounts of information about this online, about how to do this, what works, what doesn't. The reality is it's going to be particular to your organization and your developers, and your business, frankly. At a minimum, you should think about these things, right? Not changing the format of response data out from under people, right? If you're returning a JSON document, don't all of a sudden put some fields in a subdocument. You're going to break people. Don't change the response type. You might all of a sudden find a need to have some numeric value go to a float from an int. You should create a new resource or cut a new major API version. And of course, don't remove any part of the API, right? So when we're deploying continuously, you need to have confidence that that contract is staying stable. And there's all kinds of tooling out there to help you with this. You can look at, again, endless literature around contract testing. There's OpenAPI and Swagger, which help people be aware of your contract and maybe even also help them contract test against you, hopefully in your QA environment. But this is, a necessary prerequisite if you're going to go down this path. Making data store changes online. This one is near and dear to my heart as a former DBA. So obviously, if you're going to be deploying during the day and you're going to reduce, coordination and coupling, you need to have your data store changes, database migrations, whatever that looks like to you, be part of your SDLC, and you probably need a migration tool to handle that for you. You need to use data stores that allow you to do online schema changes if you're using a relational database, which I recommend. Even if you're using a database that doesn't natively support that, you might find tooling out in the world that does support that for you. So we were on MySQL 5.5 for a long time, doesn't support online DDL. Turns out Percona has a tool for that. GitHub has a tool for that, right? Put your hands around those tools, figure out how to make them work in your pipeline. And as Kurt already hit on, separate your data migrations out from your deploys. That way you know you're eating your own dog food and never going to make a backwards incompatible change to your data when you do a new deploy. In part 3, decoupling deployments from releases. Again, Kurt kind of hit on this, but you go a little bit deeper, right? I mean, the idea is that deployment should be a development and operations task, right? And so you don't want to change functionality when you deploy. Releasing new features, new functionality should be a business decision, right? So you can put those out, you can put them behind feature flags, maybe integrate it with your auth system, make it a switch on a permission or a role that you have. And now you can deploy all day long knowing that you're not going to change functionality out under a user when they don't expect it, whether that's a human user using a UI or one of your API clients calling you. This is maybe not totally trivial to implement, but again, there's many ways to do this. Think about it, start taking steps towards it. One thing I hear a lot about this is, well, this is going to introduce so much tech debt because they imagine you're going to have these big case statements in your code now. It says, if you have this feature flag enabled, then do this, else do this, blah, blah, blah. Maybe that's not the best implementation, but maybe you do that. I think the idea of tech debt is far too often used as a pejorative term. Businesses take on debt all the time to do useful things. And I think it's much more useful to think about tech debt as, yes, we are creating some work for ourselves in the future, but we're enabling some really cool functionality for ourselves today. And just put your hands around that, figure out a process to manage it. All right, so that's all the kind of software architecture stuff that you should be thinking about will work for you, whether you're doing Kubernetes, bare metal servers, serverless in the future, figure out how to take those steps. So now the more interesting part, right? Why we're all here. Kubernetes, woo! So orchestrating deployments. What is a deployment anyway? This is where we're going to get into a little bit of Kubernetes 101. So the first thing to understand about Kubernetes, and anytime you're interacting with it, is you're always making a declarative API call, right? You're describing to Kubernetes what you want, not how to do it. And so the most common workload type you'll probably put your hands around as an engineer is this idea of a deployment, right? So we have a pod. The pod is just some description of how to run a container, possibly multiple containers as one unit, but for the sake of simplicity, let's just assume it's one. So I've got some container called my service. I want to use version 1.2.3. I need it to expose port 80, and that's it. That's my pod. Deployment also allows you to create a replica set of those pods. So for scaling or for high availability, say I want 4 of those things out there. And finally, it's not explicit here, but by default, it will give you a rolling update strategy. So if anything under spec changes, again, I tell it I want version 1.2.4, Kubernetes is going to say, okay, I need to execute a rolling change to get you upgraded to that 1.2.4 version. We don't have to code that into our CI/CD pipeline. That's the real utility of Kubernetes, right? Oops. On top of that, we have this idea of a service, right? So a service is how we expose those deployments internally to the cluster in a sane way. So really it allows you to do kind of round robin load balancing. But if I have my deployment called my service and it's on port 80, I can say now I want a service to expose that. This will show up as something like myservice.namespace.svc.cluster.local. It'll get its very own IP address. Kubernetes will manage exposing that at a single IP address so that most applications that expect to do a DNS lookup, get an IP address, connect to that IP, get that same experience out of the box. You don't really have to write your application to be Kubernetes native and find the right pod or anything like that. So if we want to update our deployment, right, we've changed our image version now to version 1.2.4. We made this call sometime in the past. We're now saying this. Now Kubernetes says, okay, basically does a diff on what you had before versus what you're asking for now and figures out how to do that. So what does that look like? So we have a service here, which is this yellow box. And you can see, like I said, it exposes that at one stable IP address there, no matter, and it'll round robin kind of load balance to all the healthy pods that are back behind that service. So if we update our image spec to version 1.2.4, what's going to happen is we first bring down one of our existing pods. We bring up one at the new version, gets a new IP address, updated app. Once it becomes ready, it becomes a valid service backend, and now requests will start flowing to it. If that all looks good, it'll continue rolling forward. Take this one down, new IP address, updated app. Okay, pretty simple. There's a couple of issues we have to talk about here, though, and Kurt kind of hit on at least one of them, if not a couple. The first is bad configure secrets. So, you're often changing a config or a secret the same time you want to do a deploy, and these are kind of hard to test before you actually deploy out to that environment. And so there's no notion in Kubernetes of rolling forward or back on things like config or secrets. And so that kind of becomes a problem because you could update your config, roll out your new deploy, that deploy goes bad and rolls back, but you've still got your bad config out there. So what are you going to do about that? And the second issue, which we'll get to in a minute, is kind of what I call service layer race conditions. So bad config is too good. So if we step back and think about the general case of a deployment, there's actually many resources that are usually related to the same microservice that we want to kind of atomically be able to roll forward and roll backward. So it's not just going to be a deployment. You're going to have secrets, config, ingress rules, scaling parameters if you want to be able to horizontally automatically scale your pods out in response to any metric that Kubernetes collects. And so the question becomes, how can we manage all of this as one unit forward and back, right? Kubernetes doesn't give us a native resource that allows us to do that. So Helm to the rescue. Anybody's eyes rolling out there? No? Helm has an interesting reputation in the industry right now. I think, it's a very useful tool. There's some security concerns around it, particularly if you're running in a multi-tenancy kind of cluster, because the way that it is set up is basically you've got this templating system, you have a client that goes out to a server component running in your server that basically has cluster admin. And so it's kind of like this open pseudo server. And as long as with a minimum of just being able to list services and port forward to that tiller component, that server-side component, you can kind of do anything, depending on how you set it up. But really, if you're in single tenancy, if you're one company and you trust, your teams, I'm perfectly happy running this in those kind of clusters. And it's really helpful in two different ways. First, it allows you to create that atomic super deployment. So this is a directory listing from one of our charts that we use to run Tomcat applications. So you can see we've got our config maps, we've got our deployment spec, we've got our horizontal pod autoscaling configuration, we've got our ingress rules, we've got our secrets, and we've got our service. Now, if anything goes wrong here, I can roll this entire thing backwards. I will mention that some of the security concerns around Helm 2, which is the current version, are going to be addressed in Helm 3. They're adopting this much more native kind of controller or operator pattern where you're going to have custom resource definitions. And so you're basically going to be making API calls to a Helm controller running in there, and the security model will get much, much better. But even then, we got our config. Now, how do we make sure that our config is good before we actually start routing requests into it? Again, when I talk about the missing manual for Kubernetes, their documentation kind of reads like readiness checks are kind of just a thing that if you have an application that takes a long time to start up, you can kind of check it before you start routing requests into it. In my mind, this is far more useful for actually making sure you're ready to start accepting requests in a microservice world, because you're likely to have many dependencies. You might have database, you might have a caching layer, you might have downstream HTTP endpoints, an authorization system. And so by exploiting this readiness probe, we can actually check all of these things. Maybe in most cases in a lightweight manner, but for auth, I probably want to make sure I can actually get a token back for my service authentication mechanism. For downstream HTTP endpoints, it's probably good enough just to hit their health check, right? A very lightweight health check that just returns okay or a version, because if they're responding to me, they've already passed their own readiness checks. So they're probably healthy. And I can make sure that my configuration on how to talk to that endpoint is good. Database, again, you probably want to log in your database, do the old select one, make sure you're actually good there. And for session and caching, same thing. At least make sure you can connect to it. So the process then looks like this. So this is ideally handled by your CI/CD system, scripted out in there. But you update your values that feed into those super deployment charts. Your CI/CD system runs a Helm upgrade, set to block until it actually completes successfully on a 5-minute timeout. When new comes online, it passes the liveness check, meaning it's running. When it doesn't pass its readiness check, it's just going to sit there unready, unready, unready. 5 minutes expires, Helm cancels the upgrade and rolls everything, including my bad config, secrets, whatever, back to the known good previous release. And a bad user request never actually hit that pod. There's a bonus to doing this, defining your readiness checks. As Kurt kind of mentioned, the smoke test checks. By defining this on your service, you can very easily then turn around and create a status endpoint, right? You're already doing all the work to get this data. Why not make this an endpoint you can pull? You can cache this, you can run your actual dependency test or your readiness check and then generate it in real time. Doesn't really matter. But this is powerful, right? Developers, operators can hit your status endpoint now and see what does the service think is going on. Also, imagine taking this and actually rolling it up into a service dashboard like we're all familiar with from AWS or any other big providers that give you kind of a health dashboard, right? One other bonus that's not particularly easy to do unless you're going to script this out yourself in a CI/CD system is that Helm can actually allow you to just roll a new roll the update, even if nothing in your deployment changes, and just to configure secret changes, right? So all we're doing here is putting in an annotation on this deployment. Remember I said anything under spec changes, Kubernetes is going to roll a new version out. So just by taking a hash of my config and my secrets files, now this value changes. Now my deployment updates. All right. So again, something that's not really built into Kubernetes natively, but very simple in Helm. So you could do this all on your own. I'm not saying Helm is the only way to do this. You could certainly script this out with your CI/CD tool of choice, but Helm takes you a lot of the way there without really having to work too hard and think about it. And if you don't have to think about this, that gives your engineering team more cycles to worry about the stuff that really matters, which is solving hard business problems for your customers. So I want to talk about the service layer race condition. Developers out there hear race condition and probably think I'm talking about a bug, but I'm actually not. We're probably familiar with the term software is eating the world. And as time goes on, the reality is that eventually consistent software is eating the world, right? So what happens here? Step through the architecture. We talked about eventually consistent software, right? So nothing in Kubernetes is coordinated except for the API server itself. Nothing is consistent at any given point in time besides that API server, which is really just an etcd database with some machinery in front of it to accept and validate API calls. So if I go say create something from kubectl or whatever your Kubernetes client happens to be, that gets written there, and then all these other things are watching that and responding. They're not coordinating with each other. They're just trying to do the best they can as quickly as they can, right? And this is really fundamental to understanding everything, not only in Kubernetes, but in most modern distributed software, right? As soon as you start to coordinate all these different services, you're going to fall on your face in terms of performance, right? It just doesn't scale. This is a fundamental feature of all modern distributed software. And so we have to get familiar with that. We have to think about race conditions not being something that needs to be fixed, but how do we account for that when we code against it and when we want to operate it? So let's take a look at what can happen. So this is a simplified view of two nodes with two deployments, deployment A, deployment B. They happen to be balanced on two different nodes just to make this graph easier. Trust me, I looked for existing graphs of how to do this or diagrams of how to do this. They don't really exist. But we have, like I said, two replicas of two different deployments, and we've got services on fronting each one of those as well. The first thing you'll probably see is like, why are these IP addresses the same, right? The service layer in Kubernetes is just IP tables rules that get replicated to every single worker node in your cluster. So when this pod becomes healthy, this kube proxy is watching, and as soon as that becomes healthy, it's actually going to write a new set of IP tables rules on that local host to say, if you're looking for pods behind this service, you can go to one of these 3 IP addresses or 2 IP addresses or whatever the actual healthy pods are behind it. And so, it's really just creating a virtual IP on every single host. So when you try to connect to a service, it will destination match you over to that. So let's say pod A2 wants to talk to, service B, some pod fronted by service B. I don't care what it is. So the first thing it's going to do is do a lookup to kubedns and say, hey, what's the IP address for this? Kubedns is going to respond, you want to talk to 10.62.1.2. So pod A2 is going to send its GET request through to 10.62.1.2. Again, every service IP is resident on every worker node in the IP tables configuration. And then that's going to get destination natted. So we're just changing the destination IP address headers here to the actual one of the healthy pods behind that, in this case 10.1.1.3. And that responds directly back to the pod that make the call with an HTTP 102 OK. So that's happy path. But let's talk about what happens when a pod terminates. And I'm talking about, pod comes down as part of a rolling update for your deployment. So again, the first thing that happens is the pod is marked as terminated in the Kubernetes API server. And then any other process that's part of Kubernetes that is watching for those type of events starts to take action. So the kubelet, which is the process running on a worker node that is responsible for managing the life cycle of those pods, sees that and it sends that pod a sig term, right? SIG-term, any well-behaved runtime should take that and say, okay, I'm going to stop accepting new requests, I'm going to finish any in-flight requests I have, and then I'm going to stop gracefully. Simultaneously with that, kubeproxy sees it, and it's going to drop that terminating pod's IP from the list of endpoints that it says are behind that service. So let's jump back kind of in the middle of that last diagram here and look at what happens with this raise condition. Excuse me. So pod A2 does an HTTP GET to service B. At the same time, Kubernetes API, its pod B1 is marked terminated. The kubelet sees that. It sends a SIG term just as this request is getting destination natted over to that IP address. That process says, I'm no longer accepting, or let me take a step back. So also at the same time, this is being removed, but my request is already on the way. So at this point, my request is going to get there after pod B1 has already received SIG term, and it returns a 503. Not going to do anything for you. Well, you know, all this talk of IP tables and DNAT and all this stuff, this is getting really tedious. I feel like I'm losing you guys. Let's bring it back to maybe a little bit more understandable example. So this is Fippy and friends. We got Fippy, Zeta Zebra, Gold to the Gold, Gopher, Captain Kubi here. And they're part of the Kubernetes team, and they just had their last successful release of Kubernetes. It's out the door. They're ecstatic, bringing all these great new features for all of us to consume. And so they're going out and celebrating. Oops. This is Wisconsin after all, so we all know where we celebrate. So, you know, they're out, they're having a good time, they're celebrating their successes, and, you know, towards the end of the night, you know, people have, you know, they've had a few, and being the good servant leader that Captain Kubi is, he says, we got to get this team some food, otherwise it's going to be a real rough day at the office tomorrow. So Captain Kubi pulls out Google, searches for his service, waffles.default.svc.cluster.local, finds the local waffle shop, perfect. We're gonna go get some waffles as a team. It's gonna be great bonding. Get to the diner, get there, lights are on, super, mouth is watering for those waffles. Walk up to the door, sorry, we're closed, kitchen's closed. 503, waffles unavailable. It's gonna be a rough morning tomorrow. So it turns out I lied to you before about the process of a pod terminating. Kubernetes does give you a lifecycle hook that you can tie into called a pre-stop hook. So what actually happens is pod is marked as terminated, kubelet sees that, but if you've defined a pre-stop hook on your pod, then it is run before sending that SIG term. And then simultaneous, but still at the same time, kubeproxy sees it and drops that IP from its list. So that just looks like this. Lifecycle, pre-stop, sleep for 5 seconds. So we're delaying that SIG term hitting our container by 5 seconds, but we're also immediately dropping that IP address out of the service plane. So this is really kind of a poor man's connection draining, if you're familiar with traditional stuff. So let's take a look at how this looks. So now, again, we're right back in the middle. Pod A2 wants to call service B, does a GET. Kubernetes API, kubelet sees that pod B1 is being terminated. Now it's going to sleep for 5 seconds before it actually sends that SIG term. So the service endpoint is going to get dropped so that any future connections don't try to go to that pod, but my DNATed, my request that's already on the way has been DNATed to that IP address within a 5-second window or whatever you pick. It'll be able to get there before the SIG term. Now that IP has been dropped from my endpoints, no more requests go there, and pod B1 has a chance to service that request for pod A2. And all future requests won't even hit that, right? Pod B1 has been sent to SIG term for 5 seconds, no more requests should go there. So again, nothing real earth-breaking, earth-shattering, but you know, it's stuff that's not necessarily explicit in the manual, and this is what we found trying to go there and really get to that point where we've got no errors during our deploys. You might be able to live with some errors, but really if you want to be deploying as frequently as possible, you want to get that down to 0 ideally. And so putting it all together, version your APIs, make sure you're doing your database migrations out of band with your deployments, decouple your deployments from your releases, version as many of those Kubernetes resources related to microservice deployment as you can so that you can roll them forward and back atomically. Exploit those readiness checks to validate your own config before you start accepting requests. Use that pre-stop hook to fake connection draining and profit. So there's a couple limitations here. Ingress is really hard to work around, right? Ingress is the last thing that we haven't figured out how to test from the inside, right? So if you make an ingress rule and you screw it up, armsbusinesssolutions.com has 3 S's in the middle. You can guess how many times that's caught us up. That's really hard to protect against, so treat ingress with care. That pre-stop hook, it works. It feels a little hacky. It's a very specific edge case we're controlling for, and I'm glad it's there. But service meshes like Istio, Linkerd, whatever, account for that in the general case of having connection errors. Kurt mentioned before, automatic retry. That would solve this in the general case, plus if you just had whatever kind of transient network issues going on between your pods and your service layer. And then more complex deployment techniques can guarantee even more reliable rollouts. You notice I never have even said yet the term canary or rolling, blue-green, but at this point that does require extra machinery, whether that's you scripting it in your CI/CD system or adopting some of the other tooling that's coming out of the community, such as Spinnaker. So here we are today. I mean, this is base case 0. And when we built the business case for why we wanted to adopt a new cloud and go to Kubernetes, this is what we said we would make happen in order to justify that investment. We're going to be able to confidently deploy anytime we want without error. In the near future, we do want to progressively roll out using canary or blue-green. And that could be a human or an automated process making a decision to roll forward or back. And the beyond is really employing techniques like machine learning to automatically decide whether to roll forward or roll back. And Kurt touched on that harness IO tool a little bit, but I mean, to me, this makes tons of sense, right? If you think about how do you decide whether a deployment was successful or not, right? A human might look at, okay, is my latency stable? Have I gotten an error spike? Or maybe you look at a couple of servers that interact with this. But if you imagine a graph of hundreds of services all interacting with each other, there might be too much data for a human to look at and say, yep, this deployment was good or not, because some service way over here on the graph, you might have just broken your contract in a subtle way with just that service. And so that's where that sort of machine learning or other automated process becomes really compelling, because there's so much telemetry data pouring out of all of these services that's really the only way you can look for what is my base case of what this looks like, and then did I do a deploy and now something really weird is happening over here that I can't explain, but I know it's not good. I want to roll that deploy back. That's it. I'll take questions.
How far away are from the beyond?
Sorry?
How far away are we from the beyond?
From the beyond. Yeah, so the question is, how far away are we from the beyond, doing the AI empowered stuff? Well, there's already commercial products out there today that promise to do this. So not that far, right? I mean, I think it takes it's going to take some proving out, and like everything else, you're going to want to start with in a small way and take steps toward it. Tell you what, if we're not doing this in a year, I'll buy you a beer. Waffles, yeah, waffles and a beer. Why not? Other questions? All right, I had about 60 slides, so I'm happy with that timing. Oh, one more? Yep.
I was going to ask, have you considered some sort of sidecar process that just wanders your cluster as that health check?
As that health check. Yeah. So the question is, have we considered a sidecar process that wanders and performs that health check? We haven't, but that's probably because we've been perfectly happy with what Kubernetes is supplying us out of the box. And again, going back to Kurt's speech, we really wanted to be able to do the things we were promising the business with more or less vanilla Kubernetes, orchestration and resources. Go back to that CNCF landscape. There's all kinds of cool technology coming out in this space that may do things like that to help you out. And sidecars, are a pattern that we're absolutely exploring with Istio, right? I mean, at the end of the day, Istio is just a system that sticks a sidecar proxy next to your process, short circuits all the network calls to it, and then it can do all this intelligent routing for you so that you can keep that, advanced logic about specific protocols and configuration around number of retries out of your service layer code, right? And again, going back to Kubernetes being the current orchestration platform, that's really valuable to have that separation of concerns. I think we want to keep those separate because then it's much more easy to take my kind of core business logic code and stick it up in serverless or stick it up in whatever next cool thing that isn't even out there yet is going to do. So. If there's no more questions, I do want to ask folks to go ahead and fill out our survey. It's a short 3-question survey. We really want to make this, something that's useful for the community and keep this sustainable. So please go ahead and do that. And yeah, thanks for coming to Cloud Native Madison.